So here are some worked through samples of the questions from today. Multiplication first of all. So minus 3 times the 5, the constants minus 15. The radicals, square root of 5, square root of 20, square root of 100. Square root of 100 is 10, so minus 15 times 10, we end up with minus 150. Let's work down this way. There are a couple of different examples. So square root of 5, I think we did this. Square root of 5 to the 4th is square root of 5 times square root of 5. So I'll group them. How about we're going to have square root of 25 times square root of 25. So we can bring this root out, 5 times 5. So we end up with, for this one, 25. Multiplying through, square root of x times square root of x to the 3rd exponent. So we're going to add them when we multiply. So we're going to get the square root of x to the 4th. X squared times x squared is x to the 4th. The square root of x to the 4th is x squared. Moving on to division. There are the rules. Division is normal, pretty well. Here's a straightforward one. So 6 divided by 3 is going to give us 2. 10 divided by 5 is 2. That's the answer. Here, just the one term, so the 2 only into the minus 6, and we have minus 3. The square root of 3. Well, how many times does x go into x? 1. So it's just the root part, the radical part. So we've got 4, and the square root of 4 is square root. It's 2. And let's see, 8. So how many times does 2k go into 8k? 4 times. So the answer to that one is also 2. And maybe just one more division, a little bit trickier. Minus 2 goes into 8 minus 4 times. Subtracting exponents, we get x squared. X squared is a perfect square. We bring out the x, minus 4x. Simplifying, we're trying to look for perfect squares. And it might not have been obvious when you first looked at number 6, but it is negative square root of 36 times 2. 36 is the perfect square of 6, so minus 6 square root of 2. How about this one's a little bit different. So find a perfect square within that if we can. So 3/4 onto 4 times 14. Okay, that's maybe as good as we can do. So bring out the square root of 4, 2. So we're going to have 2 leave the 14 times the 3/4. So we have 6/4. Root of 14, simplify that to 3/2. And that should be as simple as we can make it. And I think let's take also number 11. A little bit different as well. So try to find, well, that is a perfect roots of 5 over 7 times 7. So we're bringing that up. Let's think of this in terms of maybe 5 over 1 times 1 over 7 squared. So it's the 1 over 7 squared that we're bringing out. So we're going to have 7 now, minus 7 outside of the radical, and we're left with 5 inside. And that's as simple as it gets. Expressions. Okay, so rationalize the denominator. We don't like to have denominators that are irrational. So 3. What we want to do is get rid of the irrational. So what we could do is multiply that by itself to get the square root of 5 squared, which would be 5. So we'll multiply numerator and denominator by that value, because we can multiply times 1, and square root of 5 over square root of 5 is 1. So we multiply through, and we get the numerator 5 root 5, and then we get 5. And then we can cancel out our 5's, and we've got the square root of 5. And the very next one on the next page was a little different, and well, we tried, could that be the same thing as the square root of 3 over the square root of 2? Kind of makes sense, and it does work. So that's it. We don't want a denominator, which is an irrational number, so we're going to multiply times 1 in the form of square root of 2 over square root of 2, and we end up with multiplying through square root of 6, and here we've got the square root of 2 squared, which is 2. Adding and subtracting. The thing here, and this is where well, we were running out of time, and I didn't explain this well enough, I don't think. So just think of the square root of 7 in this case as being a variable, being something. It's 9 of something plus 3 of exactly the same thing. If we have 9 of these and we have 3 of those, then altogether we have 12 of those, whatever they are. So the whatever it is, in this case, whatever those things are, is square root of 7. So if we have 9 square root of 7s and we have 3 square roots of 7, we have 12 square roots of 7. And 6, okay. Everything's in out of 3, so we can just straightforwardly add this. So we've got 11 thirds of 2, square root of 2, minus 2 thirds of square root of 2. So again, if you treat that as a variable, as an a or b or a something, it's the same something, and our denominator is the same, so we can add them straightforwardly. So here we go. We're going to go 9. 9 thirds of the square root of 2, which we can simplify as 3 times the square root of 2. Adding, well, we can't add these as they are because we don't have the same root. This isn't adding 5 of something and 5 of the same thing. They're different things at this point. So we need to see if we can rearrange things so that they become the same. So 5 square root of 2, we'll bring out the perfect square from this. So we got 25 times 2 is 50, and 25 is a perfect square, so we bring out the square root, which is 5. So it's going to be 5 square root of 2 plus 5 brought out from the square of 25, left with that. So now we have the same thing, as it were, that we were adding 5 and 5 of them together, and we're going to end up with 10 of them. 10 square root of 2's. 13 adding. So, right, let's get rid of square root of 2 from that. So it's going to be the square root of 2 over 4, can remain the way that it is, plus square root of 2 over 2. And common denominator, it's going to be 2 square root of 2 over 4. So we've got 1 square root of 2 and 2 square roots of 2 over 4, which is our answer. I'll put it over here. We have 3 square root of 2 fourths. Root. So we're going to go square root of 2 times square root of 8. It's going to be the square root of 4 times 2 minus the square root of 2. So bring out the perfect square. 2 square root of 2 minus 1 square root of 2. 2 of them minus 1 of them will leave here 1 square root of 2, which we're multiplying square root of 2 by. So just to simplify that, take the 1 out of there, make it look better. Square root of 2 times square root of 2. Now we can see that that's the square root of 4, which is 2. Solve for x. We get x by itself, so we can first of all do this addition slash subtraction. So we get 2 of them minus 1 of them leaves 1 of them. 1x of the root of 5 is the square root of 45. So we want to have our x, we're going to divide through by square root of 5, divide through square root of 5. We're left with x. It's going to be square root of 9. X is 3. And then we get the little section which stood out like a sore thumb. What the heck are we doing this for? And you find out a couple of sections later why. Doesn't matter which one we take. Let's take this one too. So a plus b is a minus b. So a remains the same. The sign becomes the opposite, so in this case plus the b. And like I say, we use this rule later, soon. Here it is multiply each of the following binomial expressions. So there's a binomial, there's a binomial. So each term here has to be multiplied by each term there. FOIL is the shortcut a lot of people use. First, outside, inside, last. So first two, we're going to have 4 multiply the inside, root 9. Outside, we're going to have minus 8 root 3. Inside, we're going to have 8 root 3. And the last, we're going to have our minus 16. And very noteworthy with this is that these cancel. The middle two terms cancel, leaving us with 4 root 9 minus 16, which we can simplify to 4 times 3 is 12. Minus 16 gives us minus 4. So remember this. We're going to be using this soon. fact, I think we're going to be using it next. So here's the last one. Last one, which we'll use difference of squares as a principle and the conjugate principle, because it's asking us to rationalize the denominator. Right now the denominator is radical and we don't like it. We want to get rid of it. And we'd be tempted to just want to go times root 3 over root 3 to get rid of that root 3, but then it's going to be root 3 times the 5, so we end up with 5 root 3, so we're back where we started. So rather what we do, the trick is to multiply both the numerator and the denominator by the same value, so in other words multiply it by 1, and that value though is going to be the conjugate of that. The conjugate of that is going to be 5 minus root 3. 5 minus root 3. So the numerator will end up being, let's just write it this way for now, 2 times 5 minus root 3. And the denominator then, using our FOIL, first outside, inside last, the first two give us 25, the outer two give us minus 5 root 3, the inner two give us plus 3, plus 5 root 3, and then the last two are going to give us minus 3, the root of 3 squared. And this, by the way, is where there was a mistake on the board that I'd written 2's there for some reason. But, so these cancel out. These wonderfully cancel out, and we end up with 2 times 5 minus root 3 over 25 minus, and then the square root of 3 squared is going to be 3. So we'll simplify this a little bit more over here. So 10 minus 2 root 3 over 22. And 2 goes into each of those, so a final simplification could be 5 minus root 3 over 11. And that's it. I'll try to at some point get an answer key with all these answers, but I think this has covered most of the kinds, if not all, of the different kinds of things you can do in this exercise.